All right, I'm back, and it is being recorded. So apologies for that once again. I think I have someone else joining. Yeah, before I begin, can everyone hear me? Is the audio okay? Thumbs up, perfect. All right, thank you very much. All right, let me share my screen. All right, I'm going to be sharing the whiteboard with you. All right, if you can't see the whiteboard, just give me a heads up on the chat. Otherwise, I'm just going to assume that you can see what I'm showing you, which is basically some text that starts with a company recently conducted a study on motivation levels. Right. So before I explain this problem, let me describe what this learning unit is about. So in the last learning unit, we did hypothesis testing. And what you basically do there is you have some sort of theory or statement made by someone. And then in order to test whether it's true in a statistical way, you gather some data, you analyze that data, and you compare it to a test statistic, and then you decide whether that statement is true. Now, in the last learning unit, which is this one, chi-square test, you're doing the same thing. The only difference is that you're using a different type of distribution to do the test. So previously, you used the normal distribution. So I'll write it here. Previously, we used the normal distribution. And if that's not too familiar with you, then maybe the symbol here might refresh your memory. We use the Z variable, the Z tables. Or you could use the T distribution. And that's what we did in the last collab. So then you would use the T-stat, all right? And then you could, for the normal distribution, you could be testing the mean, mu, or you could be testing proportions, right? So this is just a recap of what we did in the last learning unit. Now we're going to do it, but using the chi-square distribution. And you use the chi-square distribution when you are presented with a different type of question to before. And I'll explain those types of questions. There are 3 tests for chi-square tests, okay? There's 3 tests that you could be, I don't know how to find a better word, but you could be tested on in the exam. So one is you're testing independence, okay? Independence. 2, you are testing equal proportions. And I'll explain each of them in a bit more detail. So equal proportions. And then 3 is the goodness of the test. I'm just going to write GOF for short, but that's the goodness of the test. Now for 1, for independence, an example of this is, think about you trying to test whether 2 variables are independent. So let's think about an example. 2 variables could be, 1 variable is gender. You want to determine if on average males are better, or should I say run faster than females in the 1,500 meters. So your 1 variable is gender, the second variable is speed of a race. Right, so those are 2 types of variables. And another type of example is you're testing whether more work hours leads to more productivity. So the 2 variables you're testing is work hours versus productivity. Does everyone understand those examples that I gave you for independence? And do you understand what I mean by test of independence? You're testing 2 variables to see if it's independent or not. Let's go to the chat, questions. We're good, fantastic. All right, let's go back to the whiteboard. So that's the test of independence. And that's what I'm going to cover right now. Okay, so we'll look at these 2 later. But now let's just focus on the test of independence. Right. So let's read this question and determine what they're trying to ask us. Okay. So the question reads, a company recently conducted a study on motivation levels against its employees. And the HR manager wishes to establish if there's an association between the gender, so I'm going to highlight gender here, of an employee and his or her level of motivation. Okay, the following table was compiled by the survey. So what you captured in this table here is you've got males, so you have 8. So in total, you have 8 males that are highly motivated, 8 males that are moderately motivated, and 14 that have a low level of motivation. So if you add it all up, okay, should have about 30 males. Okay, 8 plus 8 is 16, plus 14 plus 30. So the total here is 30. That's how many males you have. For females, okay, you have about 21. That's about 40. You have 40 females, 19 of which are highly motivated, 12 of them are moderately motivated, and then 9 have a low level of motivation. All right, so 40 females. So altogether, you have 70 of them, right, if you add them up. So that's what you're presented with. Now, in the first question, they ask you, calculate the row percentage cross-tabulation table to show the motivation level profile for each gender and interpret each gender's profile. Okay, so what you're basically going to do is you're going to just drop the same table for part A. Okay, so all I'm doing is I'm redoing it, male, female, and then we've got highly motivated, so I'm just going to put H, moderate level of motivation, let's put MOD, and then low level of motivation, W. All right, now what they mean by row percentage is they want you to express the number, each number, as a percent of the row total. So the row total, I've already put them here. Remember, we have 30 males and we have 40 females. So for the first value, for males that are highly motivated, you take this 8, okay, and you divide it by 30 total, and you express that as percent, okay? And if you do that, you get a value of, no, someone got it done already. Yes, very good. Thanks, Joe. 26.67%. Okay, 26.67%. I'm still around it. Fine. As an maybe just to check that you're following, could you give me this value here? Females that have a low level of motivation. What is that percent? Maybe just put it in the chat. Give it a shot. So everyone probably put 9 out of 40. So it's here, you should have 9 out of 40. And that gives you a value of 22.5%. Let's see that. 22.5. Very good. Very good, everyone. Okay, so I'm just going to place the entire table here since you have an idea of how to do it. I'm going to give you the values and then we'll interpret it. Right, so I'm going to copy that, paste it here. Here we go. And if you've got a question, come to the chat. Use the SD button. Yes, yeah. Use the SD button. Thanks, Kai. And that'll convert it to a decimal. All right, so let's look. So here I've completed the table for you. Here's the percentages. Okay. Just by looking at this table, right? Who would you say, and in terms when I say who, I mean what gender is more likely to be highly motivated? Which gender is more likely to be highly motivated? Females. Yes. Yes. Very good. So you can see that, right? Females have what, almost 48% that are highly motivated, and it tailors off as you go towards the low. But for males, it's quite low for high and moderate, but for low motivated, it's quite high. So it's kind of the opposite, right? So just by eyeballing it, you can see there is a difference in behavior, right? Now, this question that we've just answered, this isn't a typical kind of question you'll get in your exam. Question A, okay? It's unlikely you will get it, but if you do, it's very simple. It's exactly like how I've shown you right now. All right. Question B is what is more likely to be in your exam. Chat. Yeah, easy marks. I'm very happy to hear people say that. I like to hear that. All right. Question B is pretty much what you're going to get. And a question like this can be around around 10 marks, okay, plus or minus 2. So let's look at question B. Now conduct a chi-squared hypothesis test to identify statistically whether there is an association between employees' gender and motivation level. Use alpha of 0.1. I'm just going to highlight that because it's going to use that value. Alpha equals 0.1. And they tell you to define the null and alternative hypothesis, state the statistical and management conclusion. Okay, all of that is pretty much just telling us to do those usual 5 steps for hypothesis testing that we've been doing in the last 3 COLAB sessions. All right. So step 1 is to declare null and an alternative hypothesis. So step 1, we're going to declare null hypothesis, H0, and our alternative hypothesis. Okay. Now, this time for the chi-square test, what they're asking you to test, okay, I'll underline what they're asking to draw your attention to it. Conduct a chi-square test to identify statistically whether there is an association between employees' gender and motivation level. This is our hypothesis. Okay. Now remember when I started off this question, I said this is a test of independence. So what you're testing is whether gender, the 2 variables you're looking at is gender and motivation level. You're trying to see whether they're independent or they're not independent, right? So you can say it like this. For your H0, you can say, and I'll write it, I'm just going to type it out instead. Okay, for H0, you can say gender and motivation levels are independent, right? That's your H0. H0 will always be that the 2 variables are independent, okay? H1 will be the opposite. So I can write the exact same thing. Now you could put not independent, right? There's a couple of ways you can do this. You can say, and I wouldn't say encourage saying not independent, just say dependent. Or, and I'll write it here, you could say, or there is an association. So, association between gender and motivation. Right, so remember this. Your H0 will always be that the variables are independent, and your H1 will be the opposite of that. So if you just remember one, you'll know the other. Okay, is that clear for everyone? Do you understand what the null hypothesis means and what the alternative one means? Very good. Great stuff. So that is your step 1 done. All right. Remember there's 5 steps. Now let's move on to step 2. So step 2 just like before in the previous collapse, here we need to find our rejection region, right? So that involves drawing our curve, graph. So just as a heads up, you don't have to draw the curve, okay? You can skip a lot of the stuff I'm doing here, but I'm just doing it to give you some context and so you understand what we're actually doing, right? But I'll show you what you do need to provide in this step. Okay, so there's the curve. For chi-square distribution, it's a bit different. It's skewed. It tails off more towards the right, and it is always an upper tail test. So the rejection region is always on the right. Okay, for chi-square test. Okay, so here that's our rejection region that I've shaded in, and the size of that area is dependent on your alpha, your level of significance here. Okay, it's your alpha, so it's 0.1. So the size of this region is 0.1. Okay, now we need to determine what is this value here on the axis. That tells me whether that's the boundary for rejecting or accepting the normal hypothesis. So anything from this value and above, we would reject H naught. We reject H naught. And anything on the left of it, we accept H naught. Okay, now the trick is to find this value. And that's where we use our table, our chi-square distribution table. And I actually have it. It's in the back of your book. It's table 3. Let me just paste it just to give you some context. Okay, here's your table. Yeah. All right, I just took a little screenshot of it. Now, what it's showing you here, if you look at the graph, okay, this can everyone see this? Let me just make it a bit larger. Okay, but if you can't see it too clearly, you can always look at the back of your textbook. Just let me know if you can see this table and this graph that I've presented here. So I'll continue. Fantastic. All right, let's go back to it. Now look at the curve I've drawn on the right and what you got in there in your table in the back of your textbook. I know my curve is obviously not identical, but I tried to make it as identical as I could. So that alpha that you're seeing here on the right, if you look at my graph, the size of the alpha is 0.1. That's the size of the area. Okay, so if you look at the table, in the first row, those are all your alpha values. So we're looking for where alpha is 0.1, and that's the first column, right? That's the first column. And now I need to figure out which row do I need to stop at, right, to get the value I need. And to do that, I need my degrees of freedom, right? Now for the chi-square test, your degrees of freedom is done in a slightly different way to how it's done in the t-distribution way, right? For your t-distribution, it would just be a sample size minus 1, right? But for your chi-square test, for the independence test, okay, for the test of independence, your degrees of freedom is given by this formula here. df, degrees of freedom, is r minus 1. I'll explain what the r is in a second, times c minus 1. Oops, c, bracket, not c, bracket, c minus 1. What the r means is how many rows do you have in your table? If you look at our table, basically, how many values can gender take on? And that's 2 values, male and female. So your R is 2. Your C is the amount of columns that you have. So how many levels of motivation do we have? So if you look at your columns, you have 1 for high, 1 for moderate, and 1 for low. So your C is 3. So your C is 3 and your R is 2. If you substitute that into this formula here, you will get 2. Try that if you want. 2 minus 1, which is 1, times 3 minus 1, which is 2, gives you 2. And that's your degrees of freedom. So now, if we're looking at the alpha is 0.1, and our degrees of freedom is 2. So it's where they intersect, which is 4.605. That's the value we're going to pull from our table. Okay, 4.605. So that's what our critical value is here. 4.605. Anything above that, we reject H naught. Anything below that, we accept H naught. Okay, everyone okay with this? Everyone following? Again, clear. Good. Fantastic. All right. So we found our rejection region. I'm going to write it a bit neater. 4.605. Okay. Now I'm going to remove all of this, and I'm going to show you what you, for step 3, what you, sorry, for step 2, what you would need to show. Okay. So all of that working, you don't have to do the curves like I did. You would need to show your degrees of freedom like what I've done. Okay. I'll write that here. So you would need to do your degrees of freedom here, like what I've explained, which is R minus 1, C minus 1, and that gives you 2. And then your chi-squared critical value is 4.605. And then you could state reject H naught if chi-squared test, whatever you find from step 3, is greater than 4.605. If you didn't want to do the graph like how I've done, then you just need to state these 3 things. Otherwise, do it the way I just did it a minute ago, the graph, and showing where the rejection region is and the acceptance region. I'll leave it to you to figure out what works best for you. Okay, but either way, one of these have to be presented, either this or then the graph like I showed earlier. All right, let's move on to step 3. Now, step 3 is the bulk of the work. Okay, so it's a lot of calculations. So bear with me in this. And if you get lost at any step, please do let me know. I'm happy to come back to it. Okay, you get, I guess, the bulk of the marks for this question in step 3. All right. So I need some space here for step 3. I'm going to clear out some stuff just to get some space here. And we already know the question. Don't need it anymore. But I need the table. Okay. Now, what I'm going to do is this table here of this data, I'm going to remove this, and I'm actually going to put the table with the totals in it. And what I mean by the totals is I've already done the row totals. Okay, study. I want the column totals as well. The 8 plus 19 will give you 27, etc. Okay, with me. I'm just going to take this out and put a neater table here with the totals. Okay, I've got a message in the chat. Just give me a second. Okay, I'll be with you in a second. Let's get to the chat. 17, sorry, being silly. Okay. All right, we'll do. All right, so all I've done is I've replaced it with another table, but it has the totals included, right? Because I'm going to need this in step 3. Now, step 3, you need to, these are what's observed, okay? This is the data that's presented to you. So that means it was observed, okay? And now what we need to work out is what is the expected value that you should see, okay? And the expected values are given by using this formula. Now, you do need to memorize this formula because unfortunately it isn't given to you in your formula sheet. So you may want to write this down somewhere or make a note of it. To get the expected frequencies, and I'm going to use FE, F subscript E, as expected frequencies because the formula uses that notation. So FE, your expected frequencies, is given by the row total times the column total all over the grand total. And when I show you examples, it's going to be pretty easy to understand how to use it. Right? Row total times column total over the grand total. Okay, so what I'm going to do is I'm just going to create a little mirror. Let me come to the chat. Please just repeat one more time. We'll do okay. Okay. So what the formula for working out the expected frequency, okay, is given by using this formula here. I'm gonna put native if we can. Okay, so row total R. I'm gonna use R for row total times column total all over the grand total. I'll explain how to use this formula, what it means, what each of them means. No worries. Okay, now I'm going to redraw the table I have on top, but now I'm going to fill it in with the expected frequencies. So I have my male on the top, female on the bottom. Okay, and columns, it's highly motivated, and it's moderately motivated. Then it's have a low level of motivation. Now, what I need to fill in each of these blocks is the expected frequency. That is using this formula here. So let's do the first one. And when I show you the first one, you're going to see it's pretty easy to do the rest of it. Okay. So let's look at this point here for males that are highly motivated. So this block here. So how we use that formula is let's look at where males are highly motivated here. Okay. From our observed data. I'm going to use this formula here to get the expected frequency. So if I am positioned here, okay, the row total for males. So if you travel along the row total is 30. So there it is, it's 30. So I'm using this formula here, right? Row total, right? Times column total. So if I'm here, what is the column total? So now you travel downwards. If you go down, the column total is 27. So 30 times 27 all over. The grand total is always fixed. It adds up every single data point that you have in the table, and that is 70. That divided by 70. Something in the chat. Yes, that is right. Thank you, Adrian. So I complete the first value. It'll be 11.57. Very good. 57. All right, let's move on to the next one. Let's work out females that are highly motivated. Okay, females that are highly motivated. I'm going to use the same formula. Okay, I'm going to leave the denominator as is because I never change it. The grand total is always the same. Here, now we are by females that are highly motivated. So now we have this point. Yeah. So here the row total is, if you travel along the row, it's 40. And the column total is still the same. It goes down 27. If you work that out, you get a value of 15.43. See, 15.43. see if you're getting the hang of it, right? Can you work out this value here for me? Males that are low using this formula, like how I showed you. Give it a shot. Get the answer and write it in the chat. So I want to see if you can work this out. What is the expected frequency for males that have a low level of motivation? Use this formula here. Excellent. Well done, everyone. Very well done. That's it. So you got the hang of it. I think everyone's got it. So I know this formula sounded a bit complicated, but as you can see, it's not. When you apply it, it's actually quite simple. Right? So you all got the right answer. It was 9.86. Even if you 9.85, it's still okay. Close enough. All right. So you would need to complete this table for all of them. All right. So I've done that for you. I'm going to write it out. I'm just going to copy and paste it. But the important thing is that you know how to calculate this table. It's very important. So give me a second. I'm just going to make some space on the board. Let's chat. Yeah, Shakir, try to round to 2 decimals as standard practice. Okay, so this is what you should have for your expected frequency. Okay, I'm going to check the chat. No worries. Okay. Okay. You've done pretty much a significant part of step 3, but we're still not done. Okay. So the next step, what I'm going to do is I'm just going to arrange this data side by side. Okay. So these 2 tables, this gives me all my observed frequencies, F0. And this table gives me all my expected frequencies, the one we just calculated now. I'm going to arrange it side by side such that these F0 and FEs are next to each other. All right, so I'm going to draw a table like this. Okay. I'm going to write males here. And then males can take on these levels of motivation. Okay, so high. I'm just going to write H for high, okay? M for moderate. Sorry. Then you've got low, okay? And then you got the same thing for females, okay? You have females who have high, moderate, low. Okay, all right. Now, in the first column next to it, I have all my F0 values. So what I mean by that is, there's your F0 values, your this table here. So where it's male and high, if you look at where that value is, it's 8. Where it's male and medium or moderate, it's 8 as well. And then male and low, it's 14, and you can see I'm playing with this. Let's do females now. Females is the next row. Highly motivated, high, 19. Okay, 12 and 9. Okay, there we go. All right. Now you do the exact same thing, but for FE values. So now you look at this table. So you get the FE values. And you enter that here. So I won't enter all of it, but you kind of get the hang of what I'm doing. For males that are highly motivated, it's 11.57. 11.57. Then the next value is 8.57. All the way to the last value for female, 13.14. Yeah, you know, 13.14. Okay, everyone follows what I just did? All I did is, I didn't do any calculation. I just wrote these 2 tables side by side. Fantastic. All right. There's a reason why I'm doing this, okay? There's a method to my madness here. So in here, I'm going to create another column, and here I'm going to start doing some calculations. All right. Okay. The next column is this here, F naught minus FE all squared. All right. So just bear with me, and I know I'm not explaining why I'm doing this calculation, but just bear with me until I complete it, and I'll show you why all of this work is needed. So as this heading of this column, what I'm doing is I'm taking my F naught value, I'm subtracting it from the FE value, and then I raise it to the power 2. So there's your F naught value here, 8. There's your FE value. So what I'm trying to work out here is F naught minus FE, so it means 8 minus 11.57, right? And then as the formula says, I'm squaring it. I put in brackets and I raise it to the power 2. And if you do that, you get a value of 12.76. I think I've got something in the chat. Let me just check it in a second. So here it's 12.76. Yes, it's close enough. 12.74, 12.75. You'll still be marked right. Yes, very good. Okay, so everyone, I'm glad to see that. Okay, so everyone's following what I need to do in this column. So I need to do that for each and every single value. Okay, you subtract these two values and you square it. If you do that for all of them, the last value you should get is 17.16. 17.16, yeah, close enough. Okay, you do that for all of it. All right, now there's one more column I need to calculate, right? And this last one is actually pretty simple. All I'm going to do is I'm going to take out what I got in this column here, whatever I got in the previous column, and I divide it by FE. That's what I'm going to do. I'm going to take everything from this previous column, and I'm going to divide it by FE. All right, so it means this 12.76, I'm going to divide it by the FE value that I get, the same row, 11.57. Okay, so let's write such here. Yeah, so I'm taking 12.76, 12.76 divided by 11.57. And I think someone's probably wrote the answer in the chat. You should have 1.102. Close enough. Let me see if that's what I'm getting in the chat. Very good. Yeah, close enough. 1.1. And you do the same thing for every single row, divided by its corresponding FE value. And if you do that, the last value you'll get is 1.306 or 1.31. All right, it's fine. So what I've done in this last column, okay, what you actually have in this last column here is you have this. You have calculated the difference all squared divided by FE, because you took everything in the previous column, which is this here in the numerator, and then you just divided it by FE. Okay, you've done all of that. Okay, now, so it's in the channel. I wish. All right, now I'm going to create some space on the board. That's what I'm going to do. Okay, the last column, this is what you have. Let me just circle this in a different color. I want to draw your attention to it. I have this here. That's what you have. Now, I'm going to rewrite this column, this table a bit neater, right? Just write it neater so I can explain it better. Yes. There we go. Much better. All right. Everything I have here is what I've just explained. All I just done it neater for you to see. So remember what I said, the last column, this column here, in this table is you have F naught minus FE all squared divided by FE. That's what you have in each single row in this last column. All you need to do now is add up all these values, sum them up in this last column. Okay, so everything I'm encircling, yeah, you add up these values. Now, if you add that up, you'll get a value of 5.043. Here's the total. So mathematically, what you've done, okay, the sign for summation in mathematics is this. Let me just change my color. It's the symbol here. Yeah, this means summation. Okay, you're summing up everything in the last column, and what you have in the last column is this. So you've summed up all of this to get this value here, 5.043. That's what you've done. Does that make sense, everyone? And there's a reason why we have to do all of this. The reason you don't have to understand right now, but you understand what this means mathematically, what you've done. Fantastic, fantastic. This, all of this work that you've done to get this, okay, this is your chi-squared test. That's the formula for your chi-squared test, okay? It's in your formula sheet. You don't really need to memorize it. If you just understand the process that I've done in this table, that's what it takes to get your chi-squared test. And remember what we said in step 2, this step here. If you look at what we're saying here, we're saying if your chi-squared test is greater than this, and in our case, it is, then that means we reject H0 because 5.043 is greater than 4.6. Does that make sense? Anyone? Did I lose anyone? We're all good? Great, 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 great. Very good. Very good. All right. So that means we reject our H0. Let's see this question. We need to redraw the tables. So Shakira, sometimes you do, but what happens in the test, the exam, what they would do is this: they'd start you off with the format. They would just give you. They wouldn't complete it for you, but they'll give you the layout like this. They'll just give you the template. They will tell you complete the values in the table in order to get the chi-squared test value. But they'll give you this layout. Does that make sense? Generally, they give you the layout for one to make the marking easier, because some people will put female first and then male second. And so, the order is different. So to keep it consistent, we will generally provide, this is how you should structure your table, but you just need to complete the values in the table. Perfect. All right. So remember what we said? Our chi-squared test is greater than 4.605. So we reject H. So we reject this. And that means this is likely true. So how we conclude this test, you would write this in a last step now, and you need to write this in words, okay? Just like before, we always start with saying the significance level, the alpha. So you always say at a 10% level of significance, because that was what our level of significance was, it was 0.1. So at a 10% level of significance, right, we find, you can just say at a 10% level of significance, we reject H0 and find that gender and motivation levels are dependent. Or, you don't have to say or, you can just one or the other. Or you can say there is an association between gender and motivation levels. So I'll just write that out just so you got it for reference. So you would say at a 10% level of significance, all right, we reject H naught and conclude there is an association between gender and motivation levels. That's what you would finish off by saying. Does that make sense, everyone? That is answering the question for hypothesis two. Fantastic. All right, glad to hear it. Okay, so that's what I wanted to cover for this session. I'm glad it seems like everyone understood the content. I'm very happy to see. So remember the recap what I said very early on. There are 3 tests for hypothesis testing, which you can get examined on. We did one of them today, which is the test of independence. So there's still the test of equal proportions, that's 2. And then the last one is the goodness of the test. And I will cover 2 and 3 in the next collab. Very, very happy to hear that. The other reasons for testing, so Kai, it's a good question. Remember I said the first one was test of independence. I'm just gonna write independence. Yeah, short form. Then equal proportions. That's the second one. And then the third one was the goodness of the test. Here. These 2 are very similar. Very, very similar. It's only the step 1 and the step 5 that are different in the hypothesis test. But everything else, all of these workings, these calculations, they're all the same for 1 and 2. 3 is different. Okay, so it's a bit different, but when you get to that, you'll see why. Okay, does that answer your question? And remember, I will cover these 2 in the next collab next week. All right, no worries. Okay, that's what I wanted to cover this evening. And yeah, and then you're completely done. Exactly. Finished. Time has flown. Okay, then. Very, very happy to hear that. Thank you. I am very happy to hear that. Okay, I'm glad it's helping. And yeah, just feel free. If there's any questions, email me, drop me a message. Otherwise, I will see you next week. Have a good evening, all. Take care.